we've got information, first of all, that's got to move up and down.
They do different jobs.
I got different jobs that have to be performed.
Order of neurons. Order of order.
Now, when you say the order of the neurons, are you thinking about like first, second, third, fourth order, first, second order, that sort of thing that was mentioned earlier? Go with yeah. Okay. Okay, the order of our neurons. Here we go. See, this is where I'll try my best to get you guys to be thinking outside the box. Okay? It's very easy to be given some information, take your test, put it back out there, and be done. Right? Right. No. I can't have that. All right? I got to get you to think about this on a higher level. All right? So far, at this area of the brain that we have looked at, where we've looked at this midbrain, the pons, the medulla oblongata, the stuff that has been primitive functions, breathing, heart rate, blood vessel diameter, swallowing, coughing, sneezing, hiccuping, visual reflexes, hearing, these primitive reflexes, okay? But now I'm showing you that we have a connection to my cerebrum. And I've already mentioned in the cerebrum, that is where we are going to find higher order thinking. For example, I use the example of when I say at 9:15, all right, go take a break, be back at 9:30. And I said, your brain is already thinking about that, getting your muscles ready for that activity, okay? Now, for that activity to take place, what's going to happen to your heart rate and your respiration, blood vessel diameter? What's going to happen to other parts of your body that you don't have to pay attention to?
They'll increase.
They're going to increase to match that activity. Why?
Because of the connection between like the primitive and the more higher level thinking.
The connection that exists that is preparing your body, the primitive portion is going to get it prepared and meet the demands of that activity.
So is that why like fight or flight?
Fight or flight's going to
happen. Like,
definitely come into play on that, yes.
Okay.
Because that primitive region, when fight or flight kicks in from the adrenal glands, this is the area it's going to act on. Now, have you ever thought of that before?
No.
This is how I want you guys to think. All right? What question did I keep asking? What did I keep asking? There was one word question that I used. Why? The strongest question you can ever ask. Why?
Is that kind of like what separates us, like makes us more like an advanced like species, because we combine like higher level thinking with primitive portions, and that like contributes to the ability to even have that?
Not so much the separation, it's the cognition. which is a higher order thinking. But other organisms who we consider like lower level, it's not that they're lower level, the communication's different. So it's just a matter of we don't understand the communication.
Is the nuclei only located in all those locations that you drew on the board?
Oh, no. I was trying to give a representation. So if we hear that term nuclei, and we think of an area of dense nerve cell bodies, okay? And we're being told where they are, okay? We're being told that some were on the anterior, some were on the posterior, this sort of thing, internal into the deep gray matter, this sort of thing. So I'm just trying to give you a representation of what can happen. For example, where it said basal nuclei of the cerebrum, well, I take that apart and I go, okay, well, this is my cerebrum. It's telling me basal, which means at the base, okay, nuclei being the dense areas. See how I came up with that? So this is my representation of what I just saw, what I just read.
And again, the reason why you said like heart rate and things like that go up is because of the connection?
There is a connection. Whenever we have to, if we're going to think about using the higher order thinking skills such as walking, standing upright, tumbling, cartwheels, running, whatever the case might be, that higher order thinking is coming from areas of the cerebrum. But if my if my body functions, like my heart rate, my respiration rate, all this other stuff is from this brainstem area, I gotta have a connection between the two, or I can't meet the demands of either one. I can't meet the demands to move my body to do what I want it to do, or anything. So we've got to have that connection.
So can you explain brain damage?
Yes. When there is brain damage to these areas, okay, in the brainstem region, for the most part, it's going to be death, okay? So if you think about any type of damage, midbrain, pons, medulla.
What about a stroke?
Now, depending upon where the stroke occurred, okay, which for the most part, strokes take place throughout areas of the cerebrum. But that doesn't mean that they can't be present in other areas of the brain, okay? Anything that takes place in the brainstem region, for the most part, instant death, okay? Because what did I say? No matter what happens, what's the ultimate cause of death? Your heart stops, okay? At the moment your heart stops, that's death, okay? Doesn't matter if it was a cancer or a traumatic accident, whatever the case might be, ultimate cause of death, the heart stops and it cannot be restarted, okay? So if you think about heart rate, now the heart is its own animal, okay? However, it is affected by areas of the brain, okay? And if you affect that brainstem area, you affect the heart rate, and the heart rate will follow, and that will be death. Now, if there's areas to the cerebellum that get damaged, the cerebellum is very much involved with our ability to be coordinated, for us to be able to maintain upright, muscle control, okay? So cerebellum usually results in a lot of physical problems being present if something is damaged. Now, areas of the cerebrum, yes, largest part of the brain, but can survive damage more. Okay? So different areas of the brain, depending on first, where did it occur in the cerebrum and how damaging was it. You can either recover fully, have minor issues, or they could be major. Okay? But the cerebrum, the chance, well, I'm not going to say chances, some damage is more recoverable. All right? But we do know, because you know, back in the early days, and when I say early days, I'm talking like when we really started getting into a lot with medicine, and even if you think back to as early as like the medieval times, when they would literally just get the dead bodies and just cut stuff up, or if something happened, like say for example the famous incident where, I'm trying to think when it happened, during one of the wars, but it was before we knew a whole lot about medicine, back in the 1700s. I want to say it was back in the 1700s. And that's back when they used the guns that had the little ball and you put the little gunpowder down.
Oh, that's Civil War. And American Revolution.
Could have been the Revolution. Yeah.
They did both.
But y'all know what kind of gun I'm talking about,
Yeah,
right?
they put the lead and they put the powder, the gunpowder.
And the bullet was this great big huge like little tiny cannonball.
Lead, yeah.
Okay? Just can't remember what the name of it is right now. My brain's going dead. So anyway, this soldier got shot in his belly, okay? And he actually survived. But he had a great big huge hole there. Well, of course, you know, people who are in the medical field and doctors, well, the doctor kind of took advantage of that. And we learned a whole lot about the acids and stuff in the stomach. Because they would actually take like a piece of meat, put it on a string, and hold it down through the hole in the belly and watch what happened to it. Okay? Oh, yeah. Before we had, roughly up until roughly the mid-1900s, so around 1950, is where we finally started having ethics added to the field of medicine. Up to that point, if y'all were to look at research and see how we learned a lot of our information, it's actually kind of scary. Okay? But now we've got all these ethics involved, and so we have to learn a lot of what we know now based on surgeries that are done, x-rays, PET scans, MRIs, this sort of thing. So that's how we kind of learn about a lot of stuff now. So we know that if they term it a lesion when there's brain damage, okay? So if you get brain damage to like the cerebrum or the cerebellum or something like that, it's termed a lesion, and therefore the area where that might be, we now know, okay, well they have damage in this area, and the result might be, okay, well maybe these 3 fingers on the hand don't work. So they now know, based on that a lesion in that area affects this part of the body. So that's how we know a lot of what we know. Now, when we look at the midbrain, is everybody kind of now following me on the connections that are present? Okay. So if we think about the midbrain, the tracts that are present, one of the things that that'll come up with the midbrain, we have tegmentum. All right. Now, what we're going to see, now look at this. Tracts from spinal cord to the brain. So that's letting me know that in the area of the midbrain, that's going to be the tegmentum, tracks from the spinal cord have a connection to the brain. Is everybody with me on that? For descending, we can get from the cerebrum to the brainstem to the spinal cord. So I now can see information pass up and down these tracks. Is everybody kind of with me on that? Okay.